let's solve a few problems that will be related to the rules that we cover in chapter 3. And the main rule for the differentiation were product rule, quotient rule, and especially the chain rule. That's the new tools that we learn in chapter 3. Okay, let's practice. Okay, that's the formulas. Some of them are from the previous chapters, but the main thing that we learn, again, product, quotient, and the chain rule. And we have to remember to apply for the trigonometric and exponential to the chain rule. Okay, let's just differentiate a few functions using all of these rules. Function number 1, f of t equals to e to the power of negative 3t plus 4. Okay? We have to find the derivative. Differentiate means finding the derivative. This one, it's no product, no quotient. It's just simply an exponential function. However, we can see the combination of two functions. Okay? That means we will use the chain rule. And I can rewrite, if that's helpful, I can use the U notation. And we do have e to the power of u, if you prefer this way. Now, differentiating, and of course, u is negative 3t plus 4. Derivative of e to the power of u is just e to the power of u, the same function, and times derivative of u, derivative of that exponent. Now, let's actually rewrite in terms of t. U, I will put back negative 3t plus 4, and derivative of negative 3t plus 4 is just negative 3. Okay, that means the final answer is negative 3 e to the power of negative 3t plus 4. I did use the chain rule for this one, okay? Then because we can see we have a chain rule, just to identify the rules, okay? Oh, my divider. Function number 2, f of t equals to 55t minus 1/3 cosine of 4t. This one I see just a subtraction of two simple functions. Power function, just a linear function, and trigonometric. However, for the trigonometric, we do have some inside value, but since it's the linear, we know what to do with the coefficient 4. Okay, let's differentiate. Derivative of 55t is just 55. 1/3 cosine of 4x. Copy constant, remember, always copy the constant, and then derivative of cosine is negative sine of the same angle times derivative of that 40, which is 4. Or if we can think about the formula, just multiply by the coefficient next to the variable 4. Okay, this means the final answer, I will have 55, negative and negative is positive, 1/3 times 4, it's 4/3, and then sine of 40. I mean, I just use no quotient rule, no product rule, no chain rule. Okay, example number 3. P at t is equal to 50 t to the power of 4 minus 6 e to the power of t. Okay. Okay, no, at t, or just in case, if you will see this notation, derivative of the function p with respect to t, dp dt, the same thing. Okay, copy 15, derivative of t to the power of 4 is 4t cubed, power rule, and copy constant 6, and derivative of e to the power of t is just e to the power of t. That means the final answer is 15 times 4, I think it's 60, t cubed minus 6 e to the power of t. Okay, problem number 4. G at t, it's equal to 4t to the power of 5 minus 3 over square root of t minus 1, actually plus, over t cubed. Okay, let's differentiate function g. 4, copy constant, derivative of t to the power of 5, 5t to the power of 4, minus, and now what I have? I have a constant, actually, let me rewrite a function, because I will come back to this. The first part was easy, but because what we can do, we may rewrite a function a little bit different, and of course, more helpful way for the derivative. That means I will copy this is not a problem, but this one, I see square root of t in the denominator. This means that t is taken to the power of negative 1/2. And then this one, t cubed in the denominator is t cubed, but t to the negative, actually, 3. Okay, that means now I can see my powers. Okay, let's come back to the derivative. This is, of course, correct. And now, copy a constant, 3, negative 3, t to the negative 1/2. Derivative is negative 1/2 t to the power of, and from negative 1/2, I have to subtract 1. It will be 3/2, but I would like to show you the process. Okay, that's done. And the same for this one. T to the negative 3 will be negative 3, t to the negative 4. Okay, let's clean this out. 20, t to the power of 4. Negative and negative will be positive. 3/2, and t is taken to the power of 3/2, and to the power of negative 4. And let's rewrite one more time, because sometimes we do not like to keep the negative exponents. That means this might be your final answer. If not, just see how we can get rid of the negative exponents. That means I will keep 3/2, and t to the negative 3/2 means t in the denominator with the positive 3/2, and 3/2 means square root of t cubed. And this one, 3, will stay t to the power of 4. Okay, quite interesting. Number 4, okay. Number 5. Number 5 is f of t, it's equal to t to the power of 4 over 3 plus 5 times ln of t. Of course, t must be positive because it's the logarithmic function. Okay, this means derivative. For this one, I will use the power form and my logarithmic function. 4, I mean t. T to the power of 4/3 is 4/3, t to the power of 4/3 minus 1. Copy a constant 5, and now derivative of the natural log of t is just 1 over t. And we do not have any chain. Let's clean it. 4 over 3, t to the power of 4/3 minus 1 is just 1/3. And 5 over t. And maybe just in case, 4 over 3 cube root of t. And this one, I think, looks good. Okay, that means just, we have to be always confident to rewrite a final answer. Okay, example number 6. Let's say this: if function y is defined as a e to the power of u, and u is another function, 6x cubed plus 2x minus 1. Okay, we have to find dy dx, derivative of the function y with respect to x. And maybe at the end, we can substitute 1 at x equals to 1. Okay, That means this is my function with respect to u. Y prime, or actually d. Okay, let's say y prime for now, because I don't want to mess up the variable. Derivative of e to the power of u is just e to the power of u, but we know that behind u we have additional function. I will follow the chain rule, times u prime. And this is my chain. Okay, now let's see. That means now y prime will be the derivative of y with respect to x. Let's substitute x. E to the power of u. U is 6x cubed plus 2x minus 1. And times u prime. Derivative of u, nice and easy, 18x squared plus 2. Okay, and let's maybe substitute 1. E to the power of 6 plus 2 minus 1. 18 plus 2 is 20. That means this is 20 e to the power of 7. But we can see that's, yes, that's the chain rule. Okay, function number 7. Function number 7 is s of t. It's equal to 30 e to the power of 1/4 t cubed plus 1. 1/4 t cubed plus 1. Okay. I mean, again, I don't have to, but I can name my inner function u. Okay, that means s of u is just 30 e to the power of u. Derivative will be, copy a constant, derivative of e to the u is just e to the u, but I know that behind u I do have a function. I will follow the chain rule and I will multiply by the derivative. That's my chain rule. Now let's substitute x, not x, t, back, e to the power of u, which is 1/4 t cubed plus 1. Now, derivative of 1/4 t cubed plus 1. Copy a constant, 1/4, derivative of t cubed, 3t squared, and derivative of 1, 0. Okay? This means the final answer, 1/4 times 30, it will be 15/2, because I can divide. And then I can also, I also have 3. Let me put all of the constants. 30, 1/4, and 3t squared in front, and then I have to copy my exponential function. That we do have 90, 30 times 3, it's 90/4t squared, e to the power of 1/4 t cubed plus 1. Probably 90/4 will be 45/2, just in case if you will see different simple value. And we, of course, not really using the calculator. Okay, function number 8, f of t equals to 7 sine of 1/6 t cubed plus 1. Okay, that means I have function sine, but I also see my u quantity. Chain rule will be applied. Chain rule. Okay, first of all, let's rewrite a function in terms of u. 7 sine of u. So simple. Derivative of 7 sine of u is 7. Derivative of sine is cosine of u times u prime. That means that's the chain rule. Let's substitute back the original variable. It will be cosine of u, and u is 1/6 t cubed plus 1. Derivative of 1/6 t cubed plus 1 is 1/6, and derivative of t cubed, 3t squared. Okay, let's clean it. Remember, we can't really touch the angle, okay? This will stay like it is. 1, 6, and 3 is 1/2. 1/2 times 7, I can just write 7/2, and I can put t squared and then cosine function. Copy u. Okay. Okay, function number 9, f of x equals to ln of x plus 1 and then x plus 1. That means now we can nicely see the division of two functions. Quotient rule, which if we have function f over function g, the derivative is f prime g minus f g prime g squared. Okay, let's apply. Derivative of my function from the top, ln of x plus 1, derivative of this is just 1/x times function from the denominator minus ln of x plus 1 times derivative of the denominator, which is 1, and then function from the denominator squared. Okay, let's distribute 1/x and let's distribute negative. Times 1, we can ignore it. 1/x times x is 1. 1/x times 1 is just 1/x. Minus ln of x minus 1. X plus 1 squared. And I can see some simplification. 1/x minus ln of x, x plus 1 squared. And I think we may still try to get the common denominator on the top. So we have 1/x and we will have x, ln of x over x. And just in case if the option, multiple choice option will be different. And then I will have 1 minus x, ln of x, all over x and all over x plus 1 squared. And I can, of course, drop that denominator down. That means this will be x, x plus 1 squared, and 1 minus x, ln of x. That means possibly this or possibly this as a final option. Okay, let's see. Number 10, let's say f of t equals to 10t e to the negative half t. Okay, that means this one is maybe not easy to detect, to notice that we do have a product between 10t and e to the negative half t. That we have to use product rule. Having f times g, derivative of this is f prime g plus f g prime. Okay, and let's do it. That means I do have my first function and I do have my second. Derivative of 10t is just 10 times the second function plus 10t times derivative of the second function, which is exponential. Derivative of e to the negative half t is just e to the negative half t and times that coefficient of t, negative half. What we can do, we can definitely simplify. We can factor out actually 10 and e to the negative half t, and then this will be 1, and this is outside, t stays, and negative half t. Okay, it looks like a good final form. Okay, what else I do have for you? Function number 11, f of x, 4x cubed sine of 1/4 of x. Again, we do not see, but we do have a product. Product rule will be applied. Let's try. Derivative of 4x cubed is 12x squared times the second function, no changes, plus the first function, 4x cubed, times derivative of the second part. Derivative of sine is cosine of the same angle times that coefficient, because it's linear function, 1/4. And we can simplify, but I mean, we can factor out something, but I will just keep it like it is. 1/4 and 4 is just 1. That means I have x cubed and cosine of 1/4 x. We can factor out x cubed. I mean x squared, but also we can leave it. Okay, what else? I do have function 12, natural log of square root 4x cubed plus 1. Okay, that means I definitely see some inner function, because I mean the compound function, square root ln of the square root and even most inner function 4x cubed plus 1. Okay, but what we will do, I will use, first of all, a property of the logarithm. Quantity 4x cubed plus 1 can be taken to the power of 1/2. And now we know that that 1/2 can travel and can be placed in front. I mean, my function theoretically looks like that, 1/2 ln of 4x cubed plus 1. At least I did eliminate one inner function. I still have my inner function. Let's say this is u, 4x cubed plus 1. And I will use the chain rule. If I will rewrite a function, f in terms of u is just 1/2 ln of u. Differentiating this will be constant. Derivative of ln of u is 1/u times u prime. That's the chain rule, the chain of the derivatives. Let's rewrite in terms of x. 1/2, 1/u, u is 4x cubed plus 1, and times derivative of this, 12x squared. Okay, that's the derivative. And we can simplify a little bit. 12/2 is 6. I can put this on the top, and this is the final answer. Okay, and I do have another one. Oh, I don't have a slide. I use it too much, too many. Okay, but let's add them because I don't want. Okay, function number 13. F of x equals to square root, and let's say 5x to the power of 6 plus 1. That means again, I do see my inner function. This is u. And that means my function looks like, I can use square root of u. And u, of course, is 5x to the power of 6 plus 1. So now let's differentiate. Derivative of the square root of u is 1/2 square root of u. If we don't remember, we can think about u to the power of 1/2 and then power rule. 1/2 u to the power of 1/2 minus 1, which is negative half. And I still have to remember, behind u, we do have a function. That means I will follow a chain rule times u prime. But let me simplify this. 1/2 u to the power of positive 1/2 in the denominator, which is square root of u. That means I was just trying to show you that that's okay, the same thing. Okay, that means one more time, derivative of the square root of u is 1/2 square root of u times u prime. That's my chain rule. Chain of derivatives, chain rule. No product rule, no quotient rule, just the chain. Okay, let's rewrite everything in terms of x. 1/2 square roots, the same like at the beginning, 5x to the power of 6 plus 1, and times derivative of 5x to the power of 6 plus 1, 30x to the power of 5. because I have to subtract. 30 divided by 2 is 15. X to the power of 5, and this one I can't really simplify. Okay, and what we can do, okay, I have another one. We can't end up with the 13 problems. P at t is defined as a 1.03 to the power of t, and we have to find derivative of t. That means we do have an exponential function, but the base is not e. That we do have additional thing in the formula. Derivative of the exponential function 1.03 to the power of t is the same function, okay? No change, but times ln of that number of the base. Okay, and that's it. But please remember, multiply by the natural log of the base. Okay, and then just one more thing. I would like you also to remember the relative rate of change. Relative rate of change. Having a relative rate of change, maybe of f of x, right? We need something. It will be simply a derivative over the value of the function. Okay, that we have to do this. And let's maybe take a function. Maybe we can take a similar function that we start with. Let's say e to the power of negative 3x plus 9. Let's find the relative rate of change of this function at 3. Okay. What we have? First of all, I need derivative. Derivative of this function is, that's the exponential function. That means derivative of this function, I can maybe write here. Derivative of this function is the same function, okay, and times derivative of this exponent. Yes, my chain rule, which is just negative 3. Okay, really good. I can substitute 3 now, e to the negative 3 times 3 plus 9 times negative 3. This is e to the power of negative 9 plus 9 times negative 3. This is e to the power of 0 times negative 3. E to the power of 0 is 1. The final number is negative 3. Okay. It means I do have my value, negative 3, yes, derivative at 3, and I also need a value of the function. I can maybe say that. What's the value of the function at 3? Function is just e to the negative 3x, x is 3 plus 9. Oh, okay, negative 9 plus 9, e to the power of 0 is 1. Okay, that means I can put 1 because the value, of course, at x equals to 3 is 1. The rate of change is negative 3. I mean the relative rate of change is negative 3. How the derivative of this function is changing with respect to the exact value of the function at that point. Okay, that means this, if you will go through all of these 15 problems, you will be definitely ready for your chapter 3 test. Thank you.